Okay, so today's lesson is distance and midpoint. We're going to start off by talking about distance, all right? Now, this is something that you should be familiar with, Cartesian coordinate plane, all right? Made up of an x-axis and a y-axis. The intersection of the two axes is called the origin, and that is 0, 0. You have your quadrants. If both x and y are both positive, that's in quadrant 1. If your x is negative, your y is positive, that's quadrant 2. If both x and y are negative, that's in quadrant 3. And if your x is positive, your y is negative, that's in quadrant 4. Each point is called an ordered pair. So those points that are labeled on the Cartesian coordinate plane is called an ordered pair. It's made up of an x and a y. All right, so you're not going to need really graph paper. I know that I gave you the packet. You could just easily sketch this. If you were taking notes, you could sketch this in your notebook. All right, so I'm going to take example 1, and I'm going to graph point A. So I'm going to move 1, 2, 3, 4, 5 on the X, 1, 2, 3, 4 on the Y. And then I count for B, -3. So that's 1, 2, 3 to the left on the X-axis, 1, 2, 3, 4 up on the Y-axis. And as you can see, as I connected the 2 points, they are in fact form a horizontal line. Horizontals you can count. You can easily count how far the 2 points are from each other. So when you are counting, be careful where you're starting at. That's 0. If I wanted to count how many tiles are on the floor in my classroom, I don't start by saying where I'm at, that's 1. No, I move, that's 1, then 2, then 3, and so forth. So here is 0. So 1, 2, 3, 4, 5, 6, 7, 8 units. All right, that's a distance of 8. All right, let's look at example 2. So 7, 1, 2, 3, 4, 5, 6, 7 on the Y on the x-axis, and 1, 2 down on the y-axis. All right, D, that is 7 on the x, and 1, 2, 3, 4, 5, 6, 7, 8 on the y-axis. As you can see, that is a vertical line. Vertical again is straight. Okay, there's no tilt to it. So you can easily count the distance here as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. All right. And then we have 3. Okay. So I'm going to go ahead and plot. I didn't use purple yet. 1, 2, 3, 4, 5 to the left, 1, 2 up. And then F is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Now, as you can see, this is at a slant. You cannot count the distance. So here we're going to have to use the distance formula. Again, you're going to have this memorized. When you take the LEAP test in January, or when you take the ACT your junior year, or whenever you choose to take it, the distance formula is not a formula that is going to be given to you. You have to have it memorized. And I can guarantee you, if you do what I tell you to do and you write it before you work every single problem, you'll have it memorized way before January. In fact, you'll have it memorized before your next test. Okay? So I take my 2 order pairs, and I've given, here's the distance formula here. All right? I label them. So my first order pair, each order pair is made up of an X and a Y. So your first order pair, I'm calling it X1 and Y1 because it's my first. Then F, that's X2 and Y2 because that's my second order pair. So I put a 2 behind it. All right. So now that I've labeled my order pairs, I take those numbers and I plug them into the formula where it goes. Again, write your formula every single time you go to work a problem. Okay, so X2 is -4. X1 is -5. Y2 is 6. Y1 is 2 squared. Okay. Now, easiest thing to do. You have a calculator. We are in a time crunch. So what you're going to do is you're going to take the meat of the problem. Okay. The meat of the problem. Let's see. I'm trying to figure out what's best. I'm going to use my highlighter. Okay. The meat of the problem is the part underneath the square root. Okay. That I just highlighted in yellow. Not the square root symbol, but what's underneath it. The meat of the problem. Okay. So you're going to type it exactly how you see it underneath the square root. Okay. Now I'm going to use my calculator just because, so it's side by side. You would have your decimals split screen here. Okay. So open parentheses, -4 minus -5, close, squared, plus, open, 6 minus 2, close, squared. Okay. You have those exact same buttons on decimals just to show you. You have your parentheses, negative. What you're going to use for a negative is the minus symbol. You can't for the graphing calculator. Make sure you close your parentheses, then hit square, then plus, open, 6 minus 2, okay, 6 minus 2, don't forget to close, then press, oh, see, it moved it, okay, it didn't like that I got out of Google, so 6 minus 2, close, then squared, okay, so 17. That is the number that's going to go underneath. Oh, I'm still on highlighter. So bring back the square root symbol, and the answer that you got from the meat of the problem, that's what goes right here. If that number can be simplified, then you work your way up the perfect square chart. It cannot. 17 is actually a prime number, so this is my simplified answer. If you're asked to write a decimal, follow the directions. If you're asked to leave it as a square root, as a radical expression, this is it. Okay? All right, so let me ask you this question. Okay? Go back to 1, all right, the first one. As a result, we got a horizontal line. And on example 2, as a result, we got a vertical line. So I want you to think for a second, okay? What do you notice in example 1? You should notice that the y value in both ordered pairs is 4. It's the same, okay? So that means that if it is the same y value, it's only going to pass through the y-axis, okay? It is something that you would have learned in Algebra 1, has been a while.
I sent you an email.
2
you can get those numbers to me
is
that would be great.
Same x value, okay? It is the same x value. So again, that's what gave us a vertical line. It's only going to pass through the x-axis, okay? It's only going to pass through the x-axis. All right, and so if you notice, 7 is the same in both. All right, I'm going to stop.